Hello, this is Mrs. Poland for the Unit 4 review sheet for Algebra 2 on statistics. In this video, I'm going to go over example 24. A school had a lot of problems with students' absences and wanted to try an intervention program to see if it would encourage students to come to school more often. As a trial, students were split into two equal-sized groups. Group 1 would get the new intervention and Group 2 got no intervention. The mean number of absence was calculated after 1 month for each group. As shown in the table below, is the difference in means statistically significant based on the simulation? So they gave us the data from the two groups and they already calculated the means. It does not matter in this particular problem if you do group 1 minus group 2 or group 2 minus group 1. You just have to be consistent in how you approach the problem. Typically, if it doesn't say anything, I'll do group 1 minus group 2. So I'm going to find the statistic, which is the difference of the sample means. And you have to use this notation, otherwise the problem's wrong. So I get 1.7 minus 2.1, which is a negative 0.4. They created this simulation, and the simulation assumes that there's no difference between the groups and then runs samples. They re-randomize these group of data 200 times, in fact, calculate the mean for both groups, and that's how they came up with the simulation. And you're going to use the results of the simulation to determine if that difference of negative 0.4 is statistical. Since it's negative 0.4, you're going to go towards the left. If you had gone the other direction, you would have gone towards the right and used the positive 0.4. And so here's a line. So anything below this point, you're going to count the frequencies. So again, this notation is important. The probability of the difference of the sample means x bar 1 minus x bar 2. How likely would you get a value of negative 0.4 or less purely by a chance and assuming that there's no difference in the means? Well, the denominator is the number of simulations, which in this case is 200. And so let's count the frequencies. So we're going to estimate. This looks like 1, this looks like 3, this looks like 7, this looks like 18, and this looks like that's 12, 14, like almost 15. So we're going to add 1 plus 3 plus 7 plus 18 plus 15. Let me take out my calculator. And I got 44. And we're going to express that as a decimal, and that becomes 0.22. So is that a large chance of happening or a small chance? And I would consider this a fairly large chance because we're going to compare it to that cutoff of 5%. And since that's greater, we say that that's likely to happen. That's a common event. So just due to natural variation. So therefore, the results are not significant. Now we need to write this as a conclusion. So the minimum you should write is the following 3 lines. And I think this is, when you start practicing it, it becomes a little simpler. So the first thing I'm going to say, since this probability is greater than 5%, it's very possible to obtain this difference purely by chance. It's like a common event, a common occurrence. Therefore, the results are not statistically significant. And therefore, we can conclude that there really is no difference in the mean absences between the two groups.